Greetings and welcome to part 2 of chapter 8. So, in the exciting first part, we basically covered doing t-tests for related samples. And so what I'm going to do here is I'm going to give you the step-by-step that you're going to want to do the way I've done before, and then give you a quick example. Now realize that the example that I'm giving you does not necessarily go into the detail that some of the other ones did, that the step-by-steps are, simply because I'm not going to go over again how to do the steps that you already know how to do. So I'm not going to go over the equations again when the equations themselves are really very simple. So this is going to be fairly short. It's basically taking information that I give you, or that you will use the equations that you have to find out, and then going through and plugging them in and finding out the answer. So, okay. Pause for a second, write this down. And now I assume you're back. So we're going to be doing the t-test for the difference between means, related or dependent samples. First thing you want to do, and what you always want to do, is you want to state the claim mathematically and verbally. This is not only for me, it's also for yourself, to make sure that you know exactly what it is that you're trying to find out. And remember, the null hypothesis, H sub 0, is that there is no difference between the two means, and H sub A, the alternate hypothesis, is that there is a difference between the two. Next, you want to specify the level of significance. Now, generally, either on questions, I'm going to tell you this, but you can generally assume that it's going to be 0.05, simply because most of science has decided that 0.05 is the magic number. Now, the degrees of freedom, again, here is n minus 1. So it's the number of pairs minus 1. 4, determine the critical value. We use the t-table for that. You're going to look it up. It's going to be a two-tailed test like before, so that you're going to be able to essentially go in and find the number in the correct column. I'm going to be uploading a t-table, z-table, and also a formula sheet that you'll be able to use during tests if you don't have yours now. Otherwise, I've actually uploaded a t-table and a z-table onto Blackboard under content. You should be able to look it up there. I'll give you a second again to write this down. Okay, so the next thing you're going to do is you're going to calculate capital D bar, and then you're going to calculate the standard error. So what you're going to do here then, you have the equations for capital E bar, you have the equations for the standard error. You're also then going to have to know how to find the standard deviation of the differences. I didn't give you that. That's in the prior lecture. That will be on the sheet that I give you. And then calculate the standardized test statistic. That's actually pretty easy, because once you've found capital E bar and then the standard error of the differences, you pretty much have them. Make a decision to reject or fail to reject the null hypothesis. If t is more extreme than the critical value, then reject. Otherwise, fail to reject. And then interpret the decision in the context of the original claim. In other words, go back and talk about how essentially it means in terms of the word problem that you were given. And if you weren't given a word problem, you get to skip that. So let's do an example. Let's do an example of what this might look like. Assume 2 matched samples, each involving 10 cases, so n equals 10. Remember, for this one, we're not looking at the individuals, we're looking at the pairs. So we're looking at the difference between the two. It's going to change in the next half of the chapter. But for this, because it's within subject, because it's matching, because it's in pairs, n is the number of pairs. And the following information. I'm already giving you some of these, so the mean of the differences is 11.65. The estimated standard error of the mean differences is 3.39. To calculate t. Assuming a 0.05 level of significance, do you reject or fail to reject the null hypothesis? And this is again where you're going to want to essentially pause and actually work this out. Okay? So I'm going to give you a minute to pause, and then I will start up again. Okay. So the answers, I'm going to give them all to you at once, since that seems to be how it's working. Since t is that equation, it's always a good idea to write your equations down on your show your work, simply because a lot of people missed questions on the last two tests because they didn't write down the equation and they somehow got the equation wrong. So it's a really good idea to write the equation down, particularly as we start to get more and more of these equations. So since we know what t is, if we plug the numbers in, we get t is then equivalent to 3.4366. We know what our degree of freedom is. It's our 10 pairs. So n is 10 minus 1. So the degree of freedom is 9. If you look that up on your t table, you're finding the critical value for the degree of freedom of 9 at alpha equals 0.05 is 2.2622. Now, since 3.4366 is more extreme than 2.2622, we will reject the null at the 0.05 level of significance. This is the minimum that you should be writing on your show your work, and I expect to see a whole lot more, okay? Because I am going to be looking at that after I basically, your tests for the most part are going to be multiple choice. So any partial credit you get is going to come from my looking at your notes. I am going to look at those. It is possible that they're going to get you more points than what Blackboard says that you're going to get in the instant after it is graded. So make sure that you write down, you show your work, and I'm going to have you take a picture of it then and email it to me as soon as you have your test done. And I mean as soon as you have it done. I do not want you dinking around and emailing it to me days later. I want it emailed at the same time so I can look through it and look through the tests and see how you did. But we're basically getting to the point where a lot of these formulas, at least up to now, are looking a bit similar. And we're talking about the same things over and over again. We're talking about means. We're talking about standard errors and standard deviations. We're talking about t-tests. And indeed, we're going to go into more detail about t-tests in the next video, because that's pretty much it for this one. The next video will involve doing a t-test for two non-related samples. And that's when it starts getting a little more complicated, just to let you know. But I would recommend that you do some of the practice questions. If there is official homework, I will let you know, although you should be doing them anyway, even if there isn't official homework. But that's the end of this video, and soon we'll get to the next one.